Okay, so for the first question, this is the question. Dx over dt minus 12x sin 3t, where the initial condition given is x naught equal to 0, right? So the first step that you need to do is to take Laplace both side equation. Okay, so taking Laplace for both sides, you will get like this: 12x sin, okay, alright. So but after that you can actually separate this one into its own Laplace minus, if you have constant then you can take it out, x sin 3t, right? So the next one is to change this this x in the domain of t into the function or domain s. So how do we do that? We know that for derivative, the Laplace is equal to s x s minus x 0, right? Okay, and then if for x is just equal to xs, and the other one, which is sin 3t, equals to, if you see in table 3.1 you will know. Okay, so 3s squared plus 3 to the power of 2, so equals to 3 over s squared plus 9. Okay, so this one you can refer to table 3.1, right? So after you have solved for each function, then you can combine, but please bear in mind that the initial condition given just now, okay, is 0. So basically this one is equal to 0, right? So if we combine all together, we will get s x s plus or minus, sorry, it's a minus 12 xs, okay, equals to 3 over s squared plus 9. Okay, we haven't finished yet. So basically this is the equation that we need to proceed for the next step. Okay, so just now you have obtained this equation. So what do we do now is factorize the xs, s minus 12 okay, so okay, so this equation were in the function of xs. So from here you want to transform it into t function, but before that actually you need to solve on this one, the denominator. since this one is not, we have no problem with this equation because it's just one order of one order equation or one order denominator. But we have s squared here, which is second order denominator. So what do we do is, please recall again, please recap the function of complex factor. Okay, if you look at the trend s squared plus 9, you cannot factorize, right? You cannot do factorization. So what you need to do is you need to follow the complex factor equation. So by referring to the complex factor equation, basically we have s squared plus 9 s squared plus d1s plus d naught. Okay, so this is the equation. You can refer to the lecture note. Alright, so if we try to make it similar, left and right side, we can see that s squared is equal to 1, d1 is equal to what? 0, right? d1 is equal to 0, while d naught is equal to 9. Okay, so from here we want to generate the complex factor. So b is equal to d1 over 2. This is the formula from the complex root. So just substitute this d1 into this one. So 0 over 2 equal to b equal to 0. Okay, and then the other one is w. The equation is plus d naught minus d1 squared over 4. So we just substitute d naught is equal to 9. So 9 minus d1 is 0 over 4. So what is the equation? The answer is 3. Okay, so the answer is 3. So how do we write this? This equation can be write like this: x s so a1 plus j b1 divided by s plus b plus jw plus alpha 1 minus j b1 s plus b minus jw plus. Alright, so this is the equation for complex root. So in this case, what do we have here is xs a1 plus j b1 s plus, okay, try to substitute 3 because our w is 3, right? Our b is 0, so this one 0, so plus 3j plus a1 minus j b1 divided by s minus 3j. And we have another function. This one is the complex root just now, but just now we have s minus 12, right? So this one is just, we can just write like this: alpha 3 s minus 12. Okay, so this is the function. Okay, so just now we have expand the equation to this one. Alright, so what do we do now is we try to equal make it equal with the initial equation just now, okay, that we need to expand. So after that, what you need to do is you have to solve on this one. You need to find what is alpha 1, you need to find what is b1, alpha 3, and so on. Okay, so you must do using Heaviside expansion method, where we have 4 methods in the lecture note, but to solve this one, I will use where I have to multiply both sides, okay, with s plus 3j, and then s equals to negative 3j. So just take any of this denominator to start, okay, and then make it equal to 0, so the s will equal to negative 3j. So you start with this. So what happen if you assume like this? The equation will become 3 over s minus 12 s minus 3j alpha 1 plus j b1. Alright. So just now we get this equation, right? By first multiply both sides with s plus 3j and s negative 3j. So after that, we substitute negative 3j into s. Okay, just substitute into s just now, substitute, then we will get this equation. Okay, after simplify, so we will get this equation. But now we cannot make it similar, okay, because left and right, we need to have this like in a j and any constant. But here the j is at the denominator, so we need to do something. So how to do to make it similar? What we need to do is, for the left side, we multiply with negative 18 minus 72j for numerator and denominator. So basically it just equal to 1, but we want to multiply so that for the bottom side we will have like this. We can factorize like this for this one into this one. Okay, so this one plus, this one minus. So when we have this like this, we can factorize like this. Okay, so this is the complex root punya, what we call it, rules. Okay, so this one, you just, for the denominator, you just multiply 3 and negative 18 minus 72j. For the right side, you just let it be like this. Okay, we just modified for the left side. So now, so after simplify the equation just now, you will get in this form. So from here, actually, you can know the value of alpha 1 and also b1, right? Just do the simultaneous equation, then you will find that alpha 1 equals to negative 1 over 102, while b1 equal to negative 4 over 102. Alright, so we have we already know these two values, so we have solved for two function. So now we move to the third one, alpha 3. Okay, so we move to this one, alpha 3. We want to find alpha 3. So how to find alpha 3? Because denominator of alpha 3 is s minus 12. So what we do is, we multiply both sides with s minus 12 and make it s equal to 12. So what happens if you multiply both sides with s minus 12 and then you substitute s equal to 12? This value will cancel off. Okay, this one will cancel off, and this value also will become 0. Okay, this also becomes 0. So what happened? It will left only this equation. Okay, and then substitute s equal to 12, you will get this value. So alpha 3 is equal to 1 over 51. Alright. So now we already have all the alpha, okay, and beta 1. So we combine all together and we will get this. Okay. So just now for alpha 1, B1, we already know. So the denominator for this one is S plus 3J, S minus 3J, and this one S minus 12. Okay, so alpha 3 is equal to 1 over 51. So what to do next is we must change this Laplace transform into inverse Laplace, right? And convert it again to T domain. But before that, we need to see the pattern. In order to change to T domain, we need to see the pattern. From the pattern, we can see that for this complex, we need to simplify first. Okay, so after simplify, you will get like this. Okay, I try to factorize the value, and then you get this. From here, I just separate each value for one denominator, so it becomes this. Okay, and after I do the inverse Laplace, okay, inverse Laplace to convert into T domain, and you can see in table 3.1 you will get this equation. Xt equals to negative 1 over 51 cos 3t plus 4 sin 3t. Okay, if you notice that this one and this one, if you combine, you will get cos. Okay, cos function. And then for this one, for j, if you combine, you will get sin function. That is why we have cos and sin function for the inverse Laplace in the function of t. So we have finished solving question number 1. So this is the final answer. Okay, don't forget to convert this also. Okay, the alpha 3, so the alpha 3 is become 1 over 51 exponent 12t. So this is the final answer. So for question number 2, for transfer function, so we have this equation. So basically, we need to linearize this differential equation first because it's in the form of nonlinear. But to do the linearization, we need to follow the step that I have mentioned in the lecture. So first step is to identify the parameter. Okay. So basically, if the question does not give you anything, any hint, so basically you have to list all the parameter. So here we have L. We start with L. And then what else? We have X naught, X1, V, Y1, and also Y2. So list all the parameter. Okay. And then what we need to do is we need to do the Taylor series expansion, right? Okay. Okay, so how do we do this Taylor series expansion? Okay, please refer your notes if you still not remember. Okay, so basically just take this one, F, just list again. Note X1, V1, or V, sorry, Y1 and Y2 equals to okay, First, you put all this equation in the form of steady state. The symbol of steady state. So L will become L bar. X naught will become X naught bar. X1 become S1 bar. V become V bar. Y1 also Y1 bar. And Y2 is Y2 bar. Okay. So continue with this symbol. Okay. We start with L. Okay, we start with L. So you need to put L. And then basically this one is supposedly you need to list everything. Okay. But I put just steady state. Okay. For example, I just put steady state. Supposedly you must list everything. Basically you must list everything in the form of steady state. Okay. Okay. So L minus L bar. This is how you do it. Plus delta F over the next one is X naught. So X naught. Again, you must list everything. Okay, but in bar, you must list everything here at the bottom. Like this one is very long, so I just skip this one. Okay, so this one is X naught minus X naught bar. Okay, so continue until you do for all X1 minus X1 bar. V minus V bar. Okay. What else? We have Y plus Y1 Y1 minus Y1 bar. And last but not least is Y2. Okay, Y2 minus Y2 bar. Okay, so this is called as Stylus series expansion. So you need to expand all the equation in the form of this one. Alright. So after that, we need to write in terms of steady state. So the Taylor series just now, you just write again the value F L X naught X1 V1 Y1 and Y2, and then we have F L bar X naught bar X1 bar V1 bar Y1 bar and Y2 bar plus F over, so this one put it in steady state. So this one is steady state. Now you must change it into deviation variable prime. Okay, because just now is L minus L bar, right? So this one is equal to prime or the deviation variable. Okay, so just do for all. Just do for all. So again, F over X naught S X naught prime, okay, plus this one X1 as steady state X1 prime. Please make sure that you don't skip any step. Later on you will miss something. V1 in a steady state, so V1 prime plus y1 steady state y1 prime, and last one is y2 in steady state y2 prime. Okay, so this is the equation. After that, if you notice that the question equation just now is this one, right? So you, because h dx a1 over dt is equal to this one, and this equal to f that you list just now. So we can make it like this. H dx 1 over dt equal to, okay, just equal to this one. Okay, so after you list all this one, make sure in front here you put in a form of deviation variable, so all is in prime symbol. Okay, right. So after that, from the initial equation that we get just now, right, if we expand, if we open the factor, then we will get this one. Okay, this both of this is just similar, right? So to solve the equation just now, we need to find all the function in the bracket. Okay, we need to find this one, we need to find this one, this one, this one, this one, this one, by using the partial differential for this equation. So that means if the partial differential equation for L in a steady state, okay, look at this equation. So find the parameter L. So parameter L is this one, right? So this one, right? So if we differentiate this, do not see the L, so we just get this x naught minus x1, right? Okay, but this equation is in a steady state, so you need to have a steady state bar on the top of the parameter. So you do for all parameter so that you can get the equation. So the next one is then the x naught in. So let's see, for x naught in this equation we only have one x naught, right? So this one I expand already. So x naught, so do not see the x naught, so we take the L. So L in a steady state must have bar. Again, I do for you delta f for delta x1, partial differential for x1 in a steady state. Again, this for x1. So x1 we only have this, right? So do not see the x1, so we have negative L. So basically negative L, because of this is a steady state, so put bar on the top side. Okay, do for all. Okay, the x1 v steady state v, so negative. sorry, v, so y2 minus y1, and then for delta y1 negative v bar, y2 is positive v bar. Okay, so after you complete this, you need to substitute all this into this equation. Alright, just substitute. So h dx1 bar over dt equals to you just follow this one, okay? So just substitute. So we get x naught minus x1 bar L prime plus L bar x naught prime minus L bar x1 prime plus y2 bar minus y1 bar v prime minus v bar y1 prime plus v bar y2 prime. Okay, so you will get this equation. And then from here you need to convert into S domain or Laplace. And then you need to take Laplace transform. And there are some additional information given in the question where L prime equal to V prime equal to 0. So what happened? We try to find L prime. Here is L prime, so this is 0. V prime also 0. V prime, so this one 0. Okay, so what left now is only h dx1 over dt equals to L bar x naught prime minus L bar x1 bar prime, and then plus v bar y2 prime minus v bar y1 prime. So this one we convert into S domain or Laplace transform. So what do we have here is hash s x, just follow this one, okay? x1 prime, please don't forget the prime, equals to L bar x naught s prime minus L bar x1 prime s plus v bar y2 prime s minus v bar y1 prime s. Okay, so this is the final answer.